Now we're going to look at writing complex numbers in polar form. So just recall that x, in terms of going from rectangular to polar, x equals r cosine theta, y equals r sine theta, and r is the square root of x squared plus y squared. And we have this kind of a structure. So if we think about this x plus yi here, this radius is like that absolute value of z, where here's the x value, here's the y value. So imaginary plane, we have that relationship. So in polar form, z would be x plus yi. So recall back up here, sorry if I'm making you dizzy. If x is r cosine theta and y is r sine theta, I can replace x and y with these respectively. So coming down to here, putting, instead of x, I do r cosine theta. Instead of y, I do r sine theta. I can factor out the r so that z equals r times cosine theta plus I sine theta. So express the complex number for I using polar coordinates. Well, what would the angle be? So I mean, one thing we can look at is, if we do a drawing, 4i is 1, 2, 3, 4. It's up here. So that angle is pi over 2. So we would set this up as z equals 4. If we want to see that, think about the square root of 0 squared plus 4 squared is the square root of 16, which is 4. So 4 times cosine of pi over 2 plus I sine of pi over 2. The other thing we could look at, and we could try to, like if it wasn't one of the standard ones that we know about, we could go off the basis that tangent of theta is y over x. So theta would be tangent inverse of y over x. We didn't need to worry about that in this case, but that's an option. And then coming down here, for example 5, find the polar form of -4 minus 4i. So there'd be 1, 2, 3, 4 in the negative direction, and then 1, 2, 3, 4 up here. So, oops, didn't mean to bump that. Sorry about that. So think about our r is going to be the square root of -4 squared plus 4 squared, or the square root of 16 plus 16, which is the square root of 32, which is 4 times the square root of 2. Now, tangent theta, we wanted to go there, would be 4 over -4 or -1. The problem with the tangent theta returns a value down here, so that's not going to help us so much, so we have to kind of think about what would it be. This implies that theta is -pi over 4, but to put it into this quadrant, we add pi to that to get us, actually, yeah, it would be 3 pi over 4. So our z would be equal to that 4 root 32 times cosine of 3 pi over 4 plus I sine of 3 pi over 4. Now, we can go, what am I saying? I made a little mistake there. I apologize. It's 4 times the square root of 2. Okay. Now, you could also, if you wanted to go back the other direction to check this, that'd be like saying 4 times the square root of 2 times, and cosine of square root of 3 over 4, sorry, cosine of 3 pi over 4 is negative square root of 2 over 2. And sine of 3 pi over 4 is positive square root of 2 over 2. So we'd have 4 root 2 times negative square root of 2 over 2 plus 4 root 2 times square root of 2 over 2 times I, which would give us our 4, -4 plus 4i. So that's a checking it. Check. But this is our answer. Okay, and that's it.